Hi everyone, Professor Bob Young here, and in this instructional video we're going to solve some nonlinear systems of equations with real number solutions. Alright, now a system of equations in which at least one equation is not linear is called a nonlinear system. The substitution method works well for solving many such systems, particularly when one of the equations is linear, as in this next example. So let's say we want to solve the system x squared minus y equals 4, along with x plus y equals -2. Now hopefully you recognize that the first equation would be the graph of a parabola, and the second would be a line. So when one of the equations is nonlinear, like the second one is there, it is usually best to begin by solving the equation for one of the variables. So let's go ahead in the second one here, and we'll just move the x over by subtracting x from both sides. So we end up with y equals -2 minus x. Now the first equation, x squared minus y equals -4, we're going to go ahead and replace y in that second equation we just solved for with the -2 minus x. And notice now we've got everything in terms of one variable. So we can come over here and things are good. So distributing the negative sign through and rearranging this a little bit, we'll get down here. We're going to get x squared minus a negative, watch those signs there, will be +2 plus x equals 4. And then we'll go ahead and subtract 4 from both sides here. And we will end up with x squared plus the x here, +2 minus 4 is -2 equals 0. And then we factor and solve and we get our two answers here, x equals -2 or x equals 1. Substituting -2 for x in equation 2 gives us y equals 0. And if x equals 1, then y equals -3. So notice in this instance, we have 2 points of intersection. So the solution set of the given system is -2, 0, and 1, -3. So notice here, they showed the line, they went ahead and graphed it and the parabola there, and it intersected in 2 points. Now, visualizing the types of graph involved in a nonlinear system helps to predict the possible number of ordered pairs of the real numbers that may be a solution set of it. See, for that same problem we just did, we may have had a parabola like in this first picture and a line that didn't intersect in any points. So when that happens, you may have no solution. Or you may have a parabola and a line that just intersect in one point, and in other courses you may have heard this is called a point of tangency. And then ours was like that third example, it intersected in more than one point. All right, now let's try one other one here. We can also use elimination on these. All right, now the graph of equation 1 is a circle, hope you recognize that. And down the line, if you go to higher level math, the second one would be what's called hyperbolas. All right, the graph of these may intersect in 0, 1, 2, 3, or 4 points. So the best thing here is to eliminate the y squared. Now, if you look at this one, elimination's good. You can just add those two together and you can see those y squares going out. So we'll end up with 3x squared equals 12. X squared is 4, and oh, here's some great exam review here. Whenever you take the square root, 2 answers, plus or -2, so be careful. No, they always forget that plus or minus. So notice when x equals 2 and we plug back into the first equation, we get y squared is 0, so y is 0. Now, boy, if this was a number, you'd really have to watch out because it could be 2 answers for y, but you can't have plus or minus 0. Poor 0 there. And -2 also produces the same answer. So the solutions are 2, 0, and -2, 0 is where they would intersect. So one note here, the elimination method works with the system in example 2, since the system can be thought of as linear where the variables are x squared and y squared. In other words, we could use substitution if we wanted to. Now, we didn't in that case, and let u be x squared and v be y squared to make that linear. But, you know, just showing you that the elimination method works well, too, if you need it to work well. So use either substitution or elimination in this section, whatever you feel is best. Professor Bob Young signing off, almost finished with the course. Who would have ever believed it?